Okay, so I'm going to grab a pen. So what I want you to do is try those out, okay? Oh, actually, including answering how they are related. Once you're done, hit unpause and then write down the definition of limacones with an inner loop. So we have two equations, technically four, but I'm going to write two on here. We have A plus B sine of theta, or A minus B sine of theta. Then we have the same thing except cosine of theta. Now the difference between without a loop and with a loop is this. This is still the same. A and B are both positive, but because A is less than B, now it is with an inner loop, and this is super important here as well. The graph of a limacone with an inner loop does, okay, pass the pole twice, not just once, not never, but twice. Remember, without the inner loop does not ever touch the origin or the pole, but this one passes twice. Now let's go do example 1G. Even though this year you guys get to graph it using technology, but symmetry test, you are still on your own by hand, okay? So what I want you to do is test it out. Why don't you try it out on your own? Okay, again, I want you to try it out on your own, okay? Start with your polar axis. Write out the definition. What are you replacing? Then go on and do the line of theta equals pi over 2. Write out the formula, like same thing, right? And then do the pole. So we want to start with polar axis. Okay. Replace theta with negative theta to see if we get the same thing back. So r equals 1 minus 2 sine of a negative theta. Well, sine, it's an odd function, so it becomes 1 minus, which is originally, and then an odd function means you can take the negative in front of it, which gives us r equals 1 plus 2 sine of theta, which is not exactly the same as the original, so it's not symmetric about the polar axis. Then we can go to the line. Theta equals pi over 2. This is when we replace theta with or by pi minus theta. So r equals 1 minus 2 sine of pi minus theta. 1 minus 2 open bracket. The difference of signs, that's sine of pi times cosine of theta minus cosine of pi times sine of theta. No, bracket. All right, so r equals 1 minus 2 sine of pi, that's going to be 0. So I have negative cosine of pi. Cosine of pi is negative 1, so negative times a negative is now a positive sine of theta. Woo, woo. It's exactly the same. So right now it is definitely symmetric about the line of theta equals pi over 2. I would take my highlighter. I'm going to highlight this. The reason I want to highlight that is because when we graph it out using decimals, it should be reflected about the y equals axis, okay? Now, the last one, did I get the pen back? Nope, let's get the pen back. Okay, the last one is your pole, which we want to replace r with negative r, okay? Oh, immediately we know that's not going to happen, so we can just X that out right away, just like that. Now, we have our A value is 1, our B value is 2, and A is less than B, so we know for sure that this right here is a limacone with an inner loop, okay? Later, I will ask you to identify the curve, okay, or the shape of the curve, so make sure we know how to recognize the graph without actually having to graph it out. All right, let's bust out our decimals to see what this looks like. Let's, we have 1 minus 2 sine of theta, so let's X, no, actually, I don't want to X that out. I'm just going to change just that to 1. Okay, so as you can see, remember we talked about it looping around the center twice, and this is exactly what's happening, okay? And I'm going to identify 0. I have a mark at 2 units, so that's where I want to plot. So 0 is 2, just like that. Then I got pi over 2 is 0. Okay, so plot that. Pi over 2 is 0. Then what's next? Then I got pi is negative 2 there. Or pi is 2 units. Okay, so go back to my graph, just like that. Then what else? 3 pi over 2, 3 units. Okay, 3 pi over 2, 3 units. 1, 2, 3. So just like that. And what else do we have on the curve? Then we have 3 pi over 2 again at 1. That's like 1 unit. Okay, so 3 pi over 2 again at 1 unit. Just like that. Okay. So it's a limacon with an inner loop. Okay. So I'm folding this and I want to go. Ready? Start at here. How about this? If I get a different color pen, would that help you see it? So we start at 0, 2. Is that 0, 2? I want to double check one more time, okay? Oh no, 0, 0, 1. I lied. That's 0, 1. I'm sorry. The 2 is right there. So I lie on that one. 0, 1. And so is pi. Okay, so 0, 1 is right there. Okay. Let's double check one more time because I think I'm a little bit off. This is pi over pi is 1 again, 0 is 1, and then 3 pi over 2 is 1 and 3. Okay. So how does it touch the center twice? What we want to do is we want to start at 0 radians, 1 unit, and we go through the center the first time to draw the loop. Okay, that's 1 time going through the center. Then we loop this around. That's a 2nd time going through the center, as you can see right there. Okay, so that's how we, and then go all the way and then back to where we started, just like that. Okay, let's try that one more time so you can see how it looped twice. Okay, so we go, loop, ready? We start at the polar axis, loop through the center, loop right there, go all the way just like that. So that is a limacon with an inner loop, and my inner loop is pretty ugly, but that's how it touches the origin twice. So now we're moving on to this part. Go ahead and bust out your technology and graph it out. It's kind of fun. I like this one, so I think you'll enjoy this one as well. Once you're done, go ahead, unpause, and then let's define our definition for a rose. Okay, so it says here, rows, what are the equations? We get R equals A times cos of an n theta, and R equals A times sine of n theta, okay? And have graphs that are rose shape. If n is never 0 and it's even, the rose has 2n petals, okay? If n is neither positive or negative 1 and it's odd, the rose has just n petals. So hopefully, you guys on those ones right there, you knew right away that there were 3 and 9 petals, okay? And then up here, if n is even, just like those right there, then you know, if it's even number, then you know it's twice. So that's 8 petals here and then 12 petals there. Okay, let's go to 1H. So again, we will do the symmetry test by hand. Okay, the first test is your symmetry with respect to polar axis. We will take out theta, replace that, replace theta with or by negative theta. So R equals 3 times sine of 4 times negative theta. This is immediately negative 3 times sine of positive 4 theta. Wah, wah, wah. Not symmetric to that. Then next we want to do the line of theta equals pi over 2. So replace theta with pi minus theta. So r equals 3 times sine of 4 times quantity pi minus theta. This is the same thing as saying 3 times sine quantity of 4 pi minus 4 theta, because then I need to bust out my difference of sine. So 3 bracket sine of 4 pi cosine of 4 theta, take away cosine of 4 pi sine of 4 theta. Okay, sine of 4 pi, that will disappear because that's 0. Cosine of 4 pi, that's going to be positive 1. So r equals 3 times negative sine of 4 theta. Because remember, this is positive 1, but this is a minus sign, so that stays still. Okay, so this is r equals negative 3 sine of 4 theta. Okay, again, not the same as the original. Currently, both of them are not symmetric. Last one is your pole. Oops. Okay, so the pole is replace r with negative r. Okay, so immediately, as you can see, none of this is working. Okay, none of this is working. So we know that this is a rose, okay, with 8 petals because n is even. Okay, n is 4. So rose with 8 petals. Our test says it's not symmetric to anything. So now let's bust out our decimals in my case and see if our algebra is correct. Okay, so I want to keep sine, put in 3, and then let's do 4. Whoa, that's super pretty. And I have purple. That's even better. Let's do, is there pink in here? Whoa. Let's see, pink. Do they have pink? Nope. A red one, good. Okay, a red rose. That's pretty. Okay. So from graphing, doesn't it seem like it's totally symmetric? Not only that is symmetric, isn't it symmetric about the x-axis, the y-axis, the origin? So technically, isn't it symmetric with about everything? Okay, so why is our algebra incorrect? So remember earlier I said that the test that I gave you, it's 99%, right? Remember we talked about this? Or 90% that it works. So the 10% that it doesn't work, I remember you have to go and use that one formula about the pole. Okay, so do the pole again, but this time replace theta with pi plus theta. Okay, all right, let's check it out. I'm out of room right there, so I'm gonna go way all the way over here. So r equals 3 times sine of 4 pi plus 4 theta. R equals 3 bracket sine of 4 pi cosine 4 theta plus cosine of 4 pi times sine of 4 theta. And sine of 4 pi, that's 0, but cosine of 4 pi is now positive. So that's a positive sine of 4 theta. Whoa, it works. It is symmetric about the pole, okay? So I'm going to highlight this. Look at it, guys. It's totally symmetric about the pole. What does it mean by symmetric about the pole? That means it's an odd function. So whatever's in quad 1, it is immediately reflected to quad 3. And whatever's in quad 2, it's immediately reflected in quad number 4. So that's why you can see that it's symmetrical everywhere. So that's awesome. So now we know why there's that 10% that the first three formulas that we have been using the entire time doesn't work. So when that's the case, make sure you guys use this extra formula to make sure it works, okay? Now let's go and sketch it out. And let's see where those were first. And looks like we know we have 8 petals from our formula. So let's look at it again before I make my dots. So we got 2 in each quad. And the tip, okay, so the radius is 1, 2, 3, 4, 5. Wait, hold on. I keep counting one circle as 1 unit, but that's not true. The longest length is 3 units, okay? So, and it looks like it's 3 units, and I'm gonna try to see if I can make 8 dots and then just go from there. Okay, so let's go. I keep counting one circle is 1 unit in decimals, but that's not true. And this is going to be a, oh, I don't need a highlighter. This is a pi over 6, but I knew it was 1, 2, 1, 2, 3. So that's 1. And I knew, let's see what the second dot is. Right in front of pi over 6 and behind pi over 3 is the second dot. All right. So there you go. Oh! And so this is, guys, symmetric about everywhere. So I'm going to go over here and make a dot there. And then go over here and make a dot here. And go over here and make a dot here. Remember, it's symmetric about the pole. That means all the quads will look just like that. All right, do I have 8 dots? 2, 4, 6, 7. Nope, I need 1 more. All right, 8. All right, now make your rows. 1 petal, 2, 3. Oh, I totally missed out, dude. Oh, that was awesome. 3, 4, 5, 6, 7, and 8. That's not too bad by hand. So as you guys saw that we were able to graph that out using decimals. Remember, years past that we were not able to use technology to help us cheat, quote unquote, then this one was a bit more difficult to graph. Now, but what if we connect this polar equation to a rectangular, not rectangular, but to algebra 2 trig, right? So instead of using r and theta, what if we go and use y equals 3 sine of 4x? Well, if we use this, then as you know, we can start with the period. The period is 2 pi divided by b, which is 2 pi divided by 4, which reduces down to pi over 2. So what's that mean is that I'm going to be able to graph the entire full circle from 0 to pi over 2. But because we are connecting it with the polar, we will go all the way to 2 pi. That means I will be able to graph 4 full periods, okay? So this is a pi over 2, so that tells me that, hey, you know what? I'm going to graph the entire sine function from 0 to pi over 2. Let me get a new pen. You know what? Let me just make all the tick marks first. And for our equation, our amplitude is 3. So we will go up 3 and down 3, just like that. And every period has 4 equal quadrants. So we will put the tick marks in. Now, even going further, half of pi over 2 is going to be pi over 4. Half of pi over 4 is a pi over 8. So think of it as each tick mark is a pi over 8. Now, over here on our not unit circle, on our polar grid, this is going to be a pi over 6. This is a pi over 3, 2 pi over 3, 5 pi over 6. And then this is going to be 7 pi over 6. And this is 11 pi over 6. This is 0. Pi over 2, it's up here. Oh, look, I already wrote pi over 2 for the periods. Why don't I just use that as well? There you go. And then this is a pi. 3 pi over 2, just like that. Oh, and then I'm missing 4 pi over 3 and then 5 pi over 3. Okay. Now, because each tick mark on our x and y coordinate here, it equates to a pi over 8. So what I will also do is kind of make it a denominator of 8 for just the main ones. How about if I use a different color for that? We will go red. So a pi over this is 8 pi over 8, just like that. It's easier. And this is going to be 8, so 4 pi over 8, just like that. And then this is going to be, this is 8, so that's going to be multiplied by 4, so 12 pi over 8. And this can be back at, if it's 2 pi over 8, it's 2 pi, so that's going to be 16 pi over 8. So that way we can see it a little bit better, like when we transfer it over to the polar grid. Okay, so let's start with going, the amplitude is 3. So that means that my max is going to be 3 and my lowest is going to be -3. And signs start to 0. So we're going to go 3, 0, down 3, and back to 0. So as you can see, this is just one full period. But the polar grid has a full circle, so that's all the way to 2 pi. So I'm just going to continue the pattern. Okay, just like this. Now, if I miss a dot or a tick mark, hopefully I will be able to spot it and fix it. So let's continue this curve. It's not going to be a really perfect curve because I'm graphing by hand here, but this will help us connect it to the polar. Okay, all right, so that's from 0 to 2 pi. So as you can see, we have all of our petals here. The max, it's 3 units long, and the first one is at pi over 8. So pi over 8 is slightly smaller than pi over 3, so let's get a different color to graph out this beautiful rose. How about if I go and see, is there a purple? Let's try purple. That's fun, huh? All right, let's do that. Sounds good. Okay, so we will start with pi over 8 and 3 units. So 1, 2, 3. So let's guess that's right there. Okay, so that's pi over 8. Then if that's pi over 8 right here, 2 pi over 8 here, 3, 4. And this is 5 pi over 8, just like that. 6, 7, 8, 9 pi over 8 is here. So what if I just add a period? Okay, a period is 4 pi over 8. So the next one is going to be 13 pi over 8, just like that. Now, how about the bottom? On the bottom, I could also have these petals out. Remember, the amplitude, it's an absolute value. So these, even though on our graph is going downward at -3, but when we are graphing out an amplitude, we're just going to go opposite directions. So this one, let's see, 1, 2, 3. So it's 3 pi over 8. Okay, and then if I keep adding a period, 7 pi over 8 is here. Add 4 over 8, so that's 11 pi over 8. And then add 4 more, so that's 15 pi over 8. So these are all the locations of my longest, or the tip of the petal, I would say. All right, so 5 pi over 8 is slightly over here, and it's going to be just like that. Okay, so I just graphed that. 9 pi over 8, it's slightly past pi. So what if we go right there? Checked. Okay, 13 pi over 8 is slightly past 3 pi over 2, so that one's right there. Check. Now we can use the symmetry, because remember we tested for symmetry earlier, and then reflect all these dots. Or just for the sake of demonstration, I'm gonna go and make a dot at 3 pi over 8, and 3 pi over 8 slightly to the right side of 4 pi over 8 there. 7 pi over 8 is above pi, so check that off. 11 pi over 8 is to the left of 3 pi over 2, and then we got the last one, 15 pi over 8, which is over here. Okay, so those are the dots, and remember this is by hand, so I'm just gonna try my best to sketch that out. So just like that, those are the tips. So that's the connection between our x and y coordinate and our polar. Now this one looks, if we were sketching it out in x and y coordinate, it's slightly easier to kind of translate that to polar grid, but they're totally related. That's why we can go back and forth.